This demo illustrates how a marketing analytics company is sharing data with some of its global partners. The company needs to be able to provision and share data in a granular way with its partners so they would only access the data they're authorized to use. The company also wants to make it easy for its partners to use their own compute engines for this analysis. So let's step into Immuta and see how to apply this use case. Looking at the Immuta data catalog here, we see several data sets we need to share both in Snowflake and Databricks. In the past, the organization has had to create multiple copies of the data and filter it based on the client's contact identifier and country of origin, as well as obfuscate data based on that country of origin. This was a very tedious process that was prone to error. It required a team of data engineers to create copies of these data sets, filter out only the rows authorized, and securely transfer the data to their partners. Taking a closer look at some of this data, we can see that we must limit their access to the data based on this unique contract identifier called the account org CD. We also need to mask any PII data like email address and IP address for all consumers outside of the United States. So now let's take a closer look at our users' attributes to enable this global security policy. Here we have two users from two different clients. They both have attributes associated with their client contact identifier, and they also have attributes associated with their country of origin. These attributes are picked up at runtime based on the user's authentication. Let's take a look at the single user global policy we've created to enable these restrictions. We have a security policy we've created here called org account and location. And if we take a closer look, we can see that by using the natural language policy builder, we don't have to be a SQL developer or a data engineer. We don't even have to be technical. Through this intuitive UI, we can define policy without writing any code whatsoever. This particular policy states that we only want to show rows where a user possesses an attribute in the account org CD column that matches their account org CD attribute that's passed in at runtime via their strong authentication. We have a second policy here where we want to mask all columns that we've discovered and tagged as PII and hash those columns for everyone except those users that possess an attribute of their country of origin equal to the United States. So as you can see, Immuta makes the creation of security policies easy and intuitive using this natural language policy builder. Now let's take a look at how these policies are dynamically enforced in our consumers' native query engines. Here we are looking at our consumers' Databricks environment. And as you can see, the clients both in Europe and the US are able to use their own Databricks accounts and dedicated compute clusters, while still accessing a single copy of the data. When we execute these same queries, we can see that the results are different based on the policy that we just reviewed. And as the policy was designed, within the US, we're seeing the sensitive data, both email and IP address, in the clear based on that customer's unique account identifier. Whereas in Europe, we're masking the PII columns, email and IP address, based on their unique account column. So the data being shared outside the United States is dynamically masked based on the country of origin attribute. We also see that the row level filtering is based and applied on the partner's contract identifier so that only the rows for those contracts they've purchased are being shared. As you can see in this short demo, Immuta reduces the friction of data shared by enforcing attribute-based access control dynamically at runtime, eliminating copies of data, and allowing consumers of the shared data to use their own compute engines for analysis.